Hello and welcome. In this episode, we are going to talk about service mesh. So what exactly is a service mesh? According to the definition, a service mesh is a dedicated infrastructure layer that you can add to your application. It allows you to transparently add capabilities like observability, traffic management, and security without adding them to your own code. So I underline without adding them to your own code. So those are the services that you can get without actually making any changes to your code. You can think of it like CNI, Container Network Interface, where CNI provides networking between containers without changing any of underlying infrastructure or network infrastructure. This is kind of the same thing, service mesh on the application side. So it provides things such as security, traffic management, and observability without us doing anything special. So that we get those free when we use them. The term service mesh describes both the type of software you use to implement this pattern and the security of network domain that is created when you use that software. So in this episode, you're going to concentrate on Istio, which is a service mesh provider. It's not the only one, but it's becoming the most popular one. So what is Istio? So Istio was created with the collaboration between IBM and Google. And it is an open source software, so it's free to use, and it's being used all over the place, internally and also in the cloud. And it provides some important features, such as secure service-to-service communication in a cluster with TLS encryption, strong identity-based authentication and authorization. Automatic load balancing for HTTP, gRPC, WebSocket, and TCP traffic. And also fine-grained control of traffic behavior with rich routing rules, retries, failovers, and fault injections. And the last one, automatic metrics, logs, and traces for all traffic within the cluster, including cluster ingress and egress. So overall, I'm really impressed with Istio. This is an intro course. We can't obviously cover everything that Istio has to offer. It's a big and honestly, could be a complex system. So in this intro, I'm trying to provide some of the basic things that you can do with Istio, such as load balancing and routing. We can't obviously cover everything in detail. For instance, TLS, I will defer that to a future presentation because otherwise this becomes too long. So hopefully this will help you get started and get motivated to look into Istio and service mesh in general. And in the future, we'll continue and we'll cover more topics. So to illustrate the benefits of using a service mesh and what problems it tries to resolve, this is a very small, obviously, use case. There are many more complicated use cases that service mesh are used for, but let's say we have this legacy application over here on the right, and the clients are currently talking to the service through a load balancer. And then this could be a legacy application, or could be an application, a non-Kubernetes application hosted either internally or on a public cloud. And our job is to rewrite this application and put that inside container and deploy it to our new Kubernetes environment. So the first step we need to do is actually then rewrite this application, use containers, and then put the containers inside, upload them in Docker Hub or other internal repository. And then when we are ready, then we can go to Kubernetes and apply the changes. That is, let's say we have this YAML file that contains our service. So we're going to issue kubectl apply -f and the YAML file. And imagine this YAML file has the logic for deploying the application and the containers into Kubernetes pods, and also create a service where some of our clients can point to. So let's go through the process. So the kubelet then will get those containers, download them into Kubernetes, and then kubeproxy creates a cluster IP and load balance those through IP tables. And then it opens a port. Now what we could do is make some code changes here and have some of our clients point to this new service. Now we have some majority of our clients still probably pointing to the old service. Now we have a fraction of those. Now we are pointing in to the new service. And let's say we even make things more complicated. Now we released a view version 2 of this application service or application. And now we kind of have some of our clients that were pointing to this new environment now point to this. So you see, it quickly gets out of hand. Now we don't really have a good overall view of how the system is performing. In order to, we have to load balance, that is deciding what percentage of load should go to the old one versus new one, and in the new environment, what load should go to the V2 application. So we have to do a lot of code changes, and those are the things that we don't want to do. And also, we don't really have a good way of providing, for instance, timeouts. What is the timeout appropriate for this application versus this? And again, we don't want to make a lot of changes. So let's say we have these requirements. The ability to dynamically load balance across service versions without code changes. Again, maybe over time you want to lessen the dependency on this and then increase the traffic to this side of the house. But again, we don't want to make any changes. We don't really client code change. We want to do that dynamically. We want to also configure timeouts, as we mentioned, retries, and fault injections outside the application. So these are really big deals if you're done any distributed application, especially large application, dealing with timeouts and retries and circuit breakers and fault injections. We have to do a lot of code inside the application and then recompile and then redeploy them. So we don't want to do that. We also want to gather telemetry metrics, distributed traces and logs. Again, there's a lot of effort if we don't have anything to help us, so we don't want to do that by ourselves. And last one, we want to enable TLS, encryption, authentication, and authorization between services. So again, we can do that, obviously, we do that today, but there's a lot of effort in that. So can we do all of this? That's the question. Without putting a lot of efforts and a lot of code changes? And the answer is yes. And this is where Service Mesh shines, and this is how it helps us. Next, we are going through the, again, animation before getting into the code. I want to make sure you understand, get your head around what the Service Mesh provides. We go through another animation and what happens when we incorporate Service Mesh into Kubernetes. Let's go over the high-level steps that are required to install Istio and also integrate that into our environment to achieve our desired goal. So the first thing that we need to do is we install Istio into our environment, and that is the command line. I'll go over that in more detail in the demo, but this basically we need to issue a command, which is istioctl install, and then where the installation is. So once we run that, it creates an what's called Istio control plane, and it's got a number of very important components. One is Pilot, Citadel, and Gallery. So Pilot provides service discovery for the Envoy sidecar. So we'll talk about sidecars in just a second, and those are also considered part of the control plane. And then there's Citadel. Basically, it enables service-to-service and end-user authentication managers. Basically, this is the security provider for our mesh. And Gallery, it's Istio's configuration, validation, ingestion, and processing and distribution component. Basically, what it means is that Gallery is a component that talks to the underlying platform, in this case, Kubernetes. So Istio is not by any means limited to Kubernetes. There are other environments that you can use that. So that provides a kind of a go between the platform and Istio to get user configuration from that underlying platform. So once we do that, the next thing that we need to do is we need to associate a namespace to the Istio. So Istio operates within namespaces. You have to tell it which namespace it should integrate with. So, and this is the command. Again, we're going to the command later on during the demo, but basically we need to create a label which is called Istio injection enable. So once we do that now, that default interface, in this case, it's now configured to be integrated in Istio. So the next thing that we need to do is we need to deploy our application into Kubernetes. And let's see how now it starts interacting with Istio. So once we do that, again, as usual, kubectl is going to get the container, and then the next thing that ICOD or the control plane does, it injects a component. This is called a sidecar. So this, in addition to our original container that we had, it also injects its own proxy or container. And this is where the magic happens, because now all the communication has to go through this proxy. So when this component calls the other component, before that it will call directly, go through the, obviously, actually through the kubeproxy, but now it goes through the Envoy. So Envoy knows everything, all the communication that's happening between components. The other thing that provides is Envoy, a load balancing, TLS termination, HTTP2 and gRPC proxies, circuit breakers, health checks, stage rollout with percentage of traffic split, fault injection, and risk practice. Obviously, the configuration are inside the control plane, but those are injected through pilot into proxy, and then it configures the proxy to do these kinds of things that we were looking for. So that's the magic that happens between our environment and now, and control plane is really through the Envoy proxy. So the next thing that it does, then it creates the service as usual. It creates the cluster IP. And in this case, we only have one service here, so just showing one service. So as long as the service created, Kubernetes informs control plane that this service has been created. And then pilot then relays this information to Envoy proxies across that namespace. So all the proxies now are aware of this new service. It also distributes the traffic rules and configuration to the Envoy proxies as needed. But right now we don't have anything. It just installed a service, and that information now, and the proxies on each one of our pods have that information. So the next thing that happens is we need to now, we are not really doing that. So right now, Istio is not doing anything. The next thing that we need to do is we need to create a gateway so that the client can talk to our services from outside. And once we run that, again, it talks through the API server into the control plane. And then it creates an ingress gateway. It also creates a virtual service for our service. So this is different from Kubernetes service. So this is its own service. And then it also distributes traffic to my service as well. For instance, we want to tell it route 80% of traffic to the old service and 20% to the new service. So this is the desired. Again, and this is not exact. The command line, obviously, the commands inside that YAML is different, but this, I'm just summarize what we want, our intention is. So again, create the ingress gateway to access the service from outside, create a virtual service so that we can actually manage now our services through that, and then distribute the traffic 80% to the old service and 20% to our new service here. So once we run that, then it opens a port. So that is the gateway from outside. It kind of isn't really, in actuality, is a node port, but it's managed now by Istio. It also now creates the load balancer here. So note that Load balancing, it will not be happening inside IP tables as before. Now Envoy, it actually manages our environment, or load balancing. So we are saying 20% send to this new service, and then the rest 80% still route to the outside environment. And then what we could do is then inside our load balancer, the only thing that really we need to make is to to change the myservice.net that originally we had in the calls we're routing to this load balancer. Now, which in the load balancer, we just say any traffic that comes to port 80 and myservice.net routed into this environment. So we are not making any changes to the client. We're just making the changes inside this load balancer. So there is no zero changes that we are making to the client. That's the beauty of Istio now. So now we have 80% traffic going that way and 20% this way. Let's say now we install version 2 of our business service. We want to route some of our traffic now from V1, increase our traffic to our Kubernetes from outside, and also split the traffic between these two services. So when we run the command again now, this time we'll have, let's say 50% still going to the old service, 10% going to the new service, and 40% still going to V1, because this is a kind of canary deployment. We want to make sure everything actually runs. So again, you're not making any changes to the client. Everything is managed now inside Istio. Now, next, I'm going to show you the environment that kind of set up on my in my environment to mimic this kind of environment high level, and then following that we go to the command line and we start actually implementing this new way of things. To represent the current system that our clients are currently using, I created a simple Java application service. So one is running on this computer that you can see is already running, and also there is another instance is running on a different machine. So I'm running it on two different machines, and I'm load balancing it here through Nginx. So this is the URL. So when this URL is hit on this, the call coming to the service, with this URL, it load balance between these two servers, the one that I just showed you. So to simulate the client, I'm going to run this from Ubuntu client. So I'm going to run curl http myservice.net/computer. When I run this, it hits one of the servers and returns information. So this one is returned by the host name, Dell laptop, and this is the OS is Windows, and this is the IP address. So if I hit that again, now this time is now returned by the other machine, which is a Lenovo. That also is Windows 10, and that is the IP address of the other machine. So this is a very simple service to simulate the external or the legacy service that we are going to move it into Kubernetes. Next, we are going to install Istio on our cluster. Istio installation is pretty straightforward. Before going into the install process, you want to make sure if you have a cluster that has a single node, that is master is the only node running, make sure you taint the master. That basically means that it will allow pods to be deployed to the master node. If you don't do that, then no pods can be installed into your master, and the Istio installation will fail, and you won't be able to actually install any application on it. So just make sure you taint that. If you have a multi-node cluster, then don't worry about it. On line 5, we're going to download the installed files into a new subfolder. Just go ahead and run that. It will download that in a couple of seconds, and that's done. Then we can then change directory into the folder that it just created, and that is Istio 1.11.1. So that was the latest version of Istio at the time of this recording. So let's go ahead and run that. And then we are now inside that folder. We want to set the bin folder, which is one of the subfolder, the only subfolder actually, to our path, because that's we need to access ICO-CTL, and that's where it lives, inside the bin folder. So let's go ahead and do that. And then on line 11, this is actually where we are going to install Istio. So the command is ICO-CTL install --set profile equal to demo. So profile means that, it really means that do you need everything? Do you need all the features of Istio, or maybe you just need the bare minimum? For our demo, we're going to install everything. So the demo profile is equal to demo. That will install all the features of Istio. In production, you don't want to do that depending on your resources, because the resources could be very high as you install, deploy new applications, and maybe you don't need everything. But during the learning process, it's good to actually install everything. So let's go ahead and run that. Now it's going to install everything, install the control plane, and install a few pods. That will take a couple of minutes depending on how much memory you have and the speed of your processes. So that's completed. Now then we can take a look at the pods that was installed as part of the installation, and that is on line 13, kubectl, get pods, -n, Istio system. So all the Istio related pods are in that namespace. So let's go ahead and do that, and you'll see that there are 3 pods created here, and ICO-D this is the control plane. So this is probably the most important part of Istio, is the control plane. So that's, you can see, is installed as a pod. You can also run analyze and make sure everything is running correctly. On line 15, ICO-CTL analyze, and it's going to analyze our newly created Istio, make sure everything is running okay. And you probably get this this warning that says that namespace is not, we haven't injected, or the default is not part of the Istio managed namespace. And we'll do that during the demo, but that's only a warning that we get here, which is a good news, which means that everything is running okay. If you recall, in order for Istio to monitor and manage a namespace, we need to run a command to do that. So we'll do that during the next section of the demo. And then we can also install dashboard, and I highly recommend doing that. On line 19, kubectl apply -f. So there is a folder called samples and add-ons, subfolder within that subfolder. And we're going to run that, and that will install the samples. And one of them is the dashboard, which is a Kiali. So on line 21, when we execute this, then we will start the dashboard, and this is the URL to it. So let's go ahead and copy and paste it into a browser. And this is the dashboard. Actually, right now there is nothing in it because we haven't deployed any application to it, but as we deploy stuff, we'll go through this dashboard and we'll talk about some of the features. Before starting our first demo, I just want to make sure we all have a clear picture of what we are going to do. What we're going to do first is deploy a couple of pods. One of them is the test client from inside the cluster that we are hitting the service, and the other one is our V1 version of our service. Then we will set up our external gateway where a client can call into. And then we also set up our distribution rules or load balancing rules, what percentage goes to the new service and what percentage goes to the old service. So to get started, let's say 20% you want to go to the new service, but 80% still going to the old service. So in order to make sure that the client won't require any changes in this example, right now, when they call in port 80 of that load balancer, the call goes to either server 1 or server 2 that hosts the legacy service. So because now we have the service here, we're going to make a change. The first change would be that when they call that load balancer on port 80, we will route the call into this service here, and then that call comes in, and then according to the rules of a load balancing, certain percentage will be called by this and again, and then the rest will be. So which means that we're going to do a redirection here. And then we open another port here, like 80, 82, and that's where Kubernetes actually call into the legacy service and call those services. So we are going to abstract the user from those services through the load balancer, and that's what we're going to do next. So we are in Visual Studio Code, and we're going to execute our first demo on line 44. The first thing that we want to do is create a new namespace, because it's easier to just create a demo namespace and then delete it. You don't want to maybe mess with your default namespace. And then on line 46, kubectl label namespace my service. That's the name of our namespace we just created. And the label would be Istio dash injection equal to enable. So basically, we're going to tell Istio that please manage this namespace. If you recall, we need to do this because Istio works per namespace. And then on line 50, we are going to deploy a simple pod for our testing purposes. So we're going to deploy this guy here. And then on line 51, we're going to capture the name of the pod we just created to be used later on. And then on line 53, we're going to deploy curl because these pods don't have curl installed. So we're going to remotely ask sh into that pod we just created, which is test pod name. And then we're going to install curl. So let's go ahead and do that. Now it's got curl installed. Now on line 56, we are going to now deploy our service, our V1 version of our service. That is, you're going to now deploy this pod. So let's go ahead and take a look at the YAML file this one here, that has the logic for it. So this YAML has two sections. First section is for deployment, and also the second section is for the service. So nothing really new here. We're going to name it whatever we want. I called it my service V1. And then the labels app service and app version V1. And their spec, we are going to say what is the mash labels. That is what pods would be part of this. So any pod that has this app service would be part of this deployment. And the template, this is the container part. We label that as app service and also version 1. So the container will, or the pod will have this labels, app service and version V1. And also under containers, again, the name, whatever, we choose to call it my service, and then the image where it's coming from. So this is basically the containerized version of the service the legacy service that we'll be porting. So the service is still running. So this is a containerized, I have a problem with that word, containerized version of that service. And then it's listening on port 8080. And the service, again, the name, we select whatever name we want to do for it. And then under selector, again, is app my service. So any pod that has this label will be part of this service. So if you recall, we just labeled our pod app my service. So that would be part of this. Then ports would be port 8080, and also target for port would be 80. So basically, the container will be listening on port 8080. The service itself also will be running on listening on port 8080. So let's go ahead and execute that. Now that's done, so we're going to capture the name of the pod we just deployed. So let's go ahead and do that. And also we're going to capture the cluster IP for the service we just created. So let's go ahead and do that. On line 62, kubectl get pod, so the name of our this pod we just created. And then we are looking for the container. So we want to see what is the sidecar that Istio deploys. So if you recall, once we define a namespace to be managed by Istio, when we deploy any pod, that pod will have additional container inside the pod. And then let's go ahead and take the, and then as you can see, there are two of them. My service, this is the name of our pod, and there's now additional container called Istio proxy. So again, this is how Istio manages our services, because now all the communication going out of this container actually goes through this, and Istio will be managing that. Okay, let's clear that. Next is we are going to now create a gateway into our service. So let's go ahead and take a look at this. So we want to do this. We want to create a gateway with the port number that clients can call into it. We're also going to define the load balancing rules, what percentage going to the new service and what percentage is going to the old services. So let's take a look at first as this YAML file, this one here. So this is where we define our gateway. So again, this YAML file has two sections. One is gateway and the other one is called VirtualService. We'll talk about that a little bit later. So in the gateway, so that is actually now, since we installed Istio, that is a kind recognized inside Kubernetes. So the kind is gateway. We select a name for it, whatever you want. I call it my service gateway. And there's spec. We are telling it to use the default ingress gateway that Istio. So Istio creates one by default. So we're going to take advantage of that. And then the port that this gateway will be listening on is port 80, and the protocol would be HTTP. And then that gateway is then bound to this service. So we create a service and then bind it to that gateway. So basically, a virtual service in Istio is the load balancer and or the service or the service that provides load balancing and routing services for Istio. So in this case, again, we select a name for it. I call it my service -Istio-SVC. This stands for service-external. So this is would be our external virtual service. The host star means any URL that comes through that gateway. So we are not making any distinction between what URL. You can if you have multiple services that will be called by different URLs, then you can specify that. For this introductory demo, and for our first application, we not just say any call that comes through port 80. And recall, this is port 80 internal, right? So that port part, when Istios create this gateway, the internal port would be 80. However, if you recall, the external port would be something different, would be like 30,007. And that's what the client will be using. So that call will be routed into our gateway here and then comes inside, and then this virtual service will be called. So what is inside this virtual service? Again, what is the gateway that is bound to? And this one is, again, my service gateway, the one that's just defined up here. So this is, we are binding it to that gateway. And then for HTTP, now we define routes and destination. So this is where we decide what percentage of our calls goes to the old service and what percentage goes to the new service. So we are talking about the load balancing here. And then there is something called step one, V1. I'll talk about that in a second. And so basically that one get 20%. And then the rest would be something called my service legacy and gets 80%. As you can see, this one doesn't have a step because this is a legacy service. It is not a pod, so it's not really managed by Kubernetes, but it's Istio, we registered that through this legacy here. So this is how we define our legacy service. So again, the kind is called ServiceEntry, and the name and the namespace, basically we specify those. And the host, we define a name for it, could be any name. And then I call it my service.legacy, and then these are the characteristics. First of all, we need to specify, because it's an external service, the location will be mesh_external. And then ports 8082. And then let me show you, first of all, what we are talking about. So basically, I'm referring to, I'm creating a new port number in our load balancer, and then expose that port 8082, then that now this service can call into. So let's take a look at our Nginx. So this is port 8082. So any service or any client that calls into this, then we call this legacy.service basically here that is defined. And these are legacy to legacy services that are listening. So Kubernetes then when we call 8082, then Nginx will route to either of these two services and does the load balancing. Okay, so that's what it is. And then the last thing that we're wondering this, where this step V1 come into play, and that is we need to define another object or kind. This is called DestinationRule, and then in that again we define a name for it, and then the host that will be related to this destination rule, and then we define. So this is basically the same service we just specified in here. So it's the same service here. Oops. And then we can define the traffic policy, the load balancer option. I'm going to use the round robin, but you can use random. It's got multiple. You got multiple options for this one. For this, our first demo, I'm just going to use round robin. So basically, every time just picks a different 50-50 or whatever the number of services behind the service behind that is going to load balance across those in a round robin fashion. And this is what when we define subsets. So V1 that we saw over here, subset V1, we are defining here as basically as by a label. So label would be version 1. So anything that has version V1 will be considered as subset V1. And then in the future, when we deploy our next version of our service, the V2, the label would be version V2. Okay, so let's go ahead and create those. And now once that's created, we are going to capture all the gateway related stuff like gateway, cluster IP, ingress port, secure ingress port if you want to use HTTPS in the future, the host, ingress host, and also URL. So let's go ahead and run those. And then the gateway URL, so that would be the one that clients would be calling from outside. And then when we echo that, so this is how the external client will be calling into this. So the next thing we need to do is we need to make some changes to the load balancer. Let's take a look here. So currently, our clients are calling, when they call into port 80, it goes, that is the URL, myservice.net. Then the service goes directly into this to service. Now we want to make a change here that when they call this URL on port 80, it actually, the load balancer will forward the call into our gateway, and the Kubernetes service or Istio virtual service, when they call the all legacy services, it goes through port 8082. So let's take a look in Nginx. So this is our client right now on port 80. You can see is load balance either of these two servers. So let's go ahead and do a quick test. As you can see, it's all the legacy services are called here, and it is not load balancing to our new service because we haven't asked it yet. The clients are, or the load balancer is still pointing to the old service. So what we're going to make a change here is I'm going to comment this too. And I'm going to uncomment. This is basically the IP address of our node, and this is the port number, node port of our service or ingress service. And also this is the part that we created, port 8082. So when Kubernetes call this IP or the IP address of this server that hosts Nginx, then the call is forwarded either load balance across the legacy service. So let's go ahead and implement those. And then basically we reload Nginx to take effect. So let's go ahead and let me clear this. Now let's go ahead and see what we get this time. As you can see, now it hits our pod. So if we hit it again, it goes through the rules of the load balancing. As you can see, most of it still goes through the old service. And then the last one, this one again, hit the our pod. So this is going, so we now accomplish this part. So we have this now rules in place. We got this port open, and then we got that port open for Istio to call. So everything looks good so far. Okay, now that we verified our gateway is functioning correctly and the load balancing is happening, we want to generate some load on line 84. Basically, what it does is basically goes to a loop and calls the service from outside or the gateway. So we're going to run this from a client from outside, so like 100 times to generate some load so we can show that in the Kiali, which is the dashboard for Istio. So let's go ahead and run that. Again, we just call this service 100 times. So let's just take a minute or so in order to data to come in. So this is the view of Kiali. You can look at the graph. Basically, the graph shows you an overview of what is happening inside that namespace. To drill down more into the application level, we can go to application and click on my service. And then you can see this is the flow. If you look, because now the calls are coming all from the gateway. So if you click on, this is our gateway, and we can see now the traffic is now, most of it is still going to the legacy. And then the rest of it is coming to our pod. Is 76 to 23, is not quite 80-20, but it's close enough in the ballpark. So this is a great way for Kiali to view all your traffic and see what's going on. You can also look at the traffic. In this case, we have the gateway that calls into the virtual service. And then you can also look at the logs, so what's coming down the through the service. So this all logs are available here. You can download those. If there's any inbound metrics, we don't really have anything. And outbound, it provides a really great information for that. So you can also look at the services, and then this is my service we just looked at. I can also look at the Istio configuration, various objects that you created, such as the gateway, the virtual service, the external service. So if you click on any of those, you can view them, the YAML that is generated for that. You can make changes to it and reload that, although I wouldn't recommend doing that, but it's possible. During the test, if you want to, don't want to just command line, go to command line every time, you can come here and do that, but I wouldn't advise that in the production environment. So this is, obviously there's a lot more into the Kiali, the presentation and logs and reports. We probably will need to spend another video on those. So this is just an intro to just show you the overview of what Istio is. So this is the picture of our cluster so far. We got the V1 application service running. We got 20% of calls goes to this, and 80% still going to the legacy. Now next, what we're going to do is deploy V2 of the same service, and we're going to change the load as 20% to V1, 10% to V2, because that's a canary deployment, and 70% still going to the legacy systems. Okay, on line 88, we have the command to deploy the version 2 of the service. And this is the YAML file that contains the logic. Is pretty much like the same on the V1. The only difference is we bumped the version to V2, and also the container that we are getting from Docker now is version 2 of our service. So let's go ahead and run that. That's created. Now we want to make the load 70, 20, 10. So this is the logic, again, is the same service. And the only difference here is we added V2 also as part of the load. So it's 10%. So 20% V1, 10% V2, and 73% V3. So let's go ahead and run that. That's done. Now we want to, again, create some load from the client or client from external client. So let's go ahead and run that. Just see the graph. So this is the overview of the graph. And if we want to drill down, we can go to the service. and then click here because all the traffic is coming from the ingress, external egress. So as you can see, 70% is going through the legacy, and the rest, 30% is going through V1 and V2. And the majority of the call is still going to V1, about 71% of the 30%, and the rest is going to V2. Next, we will take a look at timeout, retrial, and fault injection, and that is on line 96. Let's take a look at the YAML file. So in this scenario, let's say we are becoming more confident that our new service can handle our requirements, handle the load. So we are going to send 50% of the total load to application V1, 30% to V2, and 20% to the legacy service. Let's also assume that we want to set timeout. So in this case, we have setting the timeout of 2 seconds. So if any of the services fail, timeout within 2 seconds, I just throw an exception. Don't wait for longer than 2 seconds. So we don't want to keep our clients waiting before they know something has gone wrong. We also add retries. So number of retry is three times, and time or per timeout 2 seconds. That is, we do 3 times. We try 3 times to call whatever service that failed, and then we wait 2 seconds between those 3 retrial. So this is the scenario. So before actually running that, let's go ahead, and I'm going to the service. So this is the legacy service. We're going to stop this. I'm going to stop this service, and also I'm going to stop this service. And let's say we are going to see what the consequences are if we don't specify a timeout. So I'm going to run that. As you can see now, the service has crashed. So the timeout will be actually significant. So the client has to wait, great amount of time just waiting for it to fail. So we don't want that. That's why we implement that policy that the client, the service should not wait more than 2 seconds in order to come back. Okay, finally it came back and says that it failed, basically timeout. Okay, let's go back to here and run our logic. Now we're going to apply the 2 seconds timeout. Let's go ahead and run that. And then let's go back and rerun this. And now it's waiting, but it's quicker. So it was much quicker than before. As you can see now, when we hit the wait, it's just going to take and come back quickly. So this was, again, this provides a lot of great benefit of taking advantage of that retrial and in your applications. The final scenario is that we want now to remove the legacy piece. We are now very confident that the new service can handle all the loads. We've done all our testing. So let's take a look at the YAML file, and this is very simple. We remove the legacy reference to it, and we are going to send 70% to V1 and 20% to V3. Okay, let's go ahead and execute that. And then now we can, for this one, we're going to run this actually from a client. So it's going to execute just sh into the test pod, and we're going to run this 100 times. We're going to call the service 100 times. So let's go ahead and do that. Okay, that's completed. Now let's go to Kiali and take a look. So let's go ahead and refresh this. Let's go to application. And since we did that from test, so we're going to test pod and take a look at it. So you will see that now the load is split between V1 and V2. So we achieved our goal now. We retired our legacy service, and now everything is running nicely in a new environment in Kubernetes.